Hi, in the previous tutorial, we learnt one-dimensional array. Don't you think arrays make programming a lot easier? When we work with an array that is a long list of names or numbers, at times we often need a specific information out of the list quickly. Searching techniques enable us to accomplish that. There are many techniques to search elements in an array. In this tutorial, we will discuss two commonly used searching techniques, that is, linear search and binary search. These are also key techniques that will help you become a better programmer. Let's start with the linear search technique. In this technique, we compare each value of the array with the given element to be searched for one by one. Since we search for the elements by traversing the array sequentially, this algorithm is named as sequential search. Here is the code to understand this better. The code first allows the user to enter number of elements in the array. After that, it accepts the element of the array from the user. Next, it asks the user the number which is to be searched. Next, the program uses a for loop to search the number in the array. It compares each element of the array with the item to be searched for one by one, starting from the first element. If the search element is found, it prints the location of the item on the screen and then breaks the loop. However, if the loop is finished and search item is not found, it prints on the screen that the value is not present in the array. Let's execute the code. We enter 10 elements. Next, we enter 58 as the target element. On the screen, we get the location of the target element, that is 58, on the screen. The best case of linear search is when the element to be searched is equal to the first element of the array. In this case, only one comparison will be made. Likewise, the worst case will happen when the element that is to be searched is the last element of the array. In this case, so many comparisons will take place and the entire process would be time consuming. To save on time, binary search is very useful. Let's understand this technique. This technique is used for locating the position of an item in a sorted array. Remember, you need a sorted array to use this technique. Let us consider an example to understand this technique. Here, we have an array of 10 elements and we wish to locate the number 34 in the array. For this, we split the 10 elements into two halves, that is 10 divided by 2. The result is 5, so we check the fifth element. The fifth element is 28, which is less than 34. Thus, the searched value is higher in the list, that is, a larger index is needed. Now, we split the 5 elements in the second half of the list into half, that is 10 minus 5 divided by 2. The result is 2.5, which can be rounded to 3. The third element in the second half is actually the 8th element of the entire array. At the 8th position, 57 is located, which is greater than 34. So, we search the number in the lower list, that is, a lower index is needed. At last, we split the distance between the 5th and the 7th element into half, 7 minus 5 divided by 2. The result is 1, so we check 1 plus 5, that is, 6th element of the array. The 6th element is 34, which is the number we are looking for. So, in this way, in binary search, the target element is searched in smaller segment, which is nearly half of the previous segment after every stage. Here's the code which is demonstrating this technique. First, the code allows users to enter number of elements in the array. Next, it allows users to enter element of the array in ascending order. Next, it asks for the number to be searched. Next, it finds the middle value of the array and then compares the element to be found with the middle value. If the middle value is less than the element to be searched, then it searches the element in the lower half. Else, if the middle value is equal to the searched element, it prints the location of the element and breaks the loop. Else it finds the element in the other half. And if the element is not found in the entire list, it prints a message, not found. The element is not present in the list. Let's run the code in the editor. We enter 10 elements in ascending order. Next, we enter 34 as target element. As a result, location of 34 is printed on the screen. That's it in this tutorial. So now what are you waiting for? Please go ahead and take the code challenge to practice further.